Despite all the problem solving that we encounter on our past subjects in our course, Aeronautical Engineering, thrust and power coefficient formula is one of the most complicated equations that we've seen. It is prone on errors, and the final answer has the chance to be inaccurate due to the complicated arrangement of terms. That's why our professor Engineer Delecano tasked us to do a program that computes for the thrust and power coefficient for an automated computations and for better accuracy in analysis.
What is blade element momentum theory? The blade element momentum theory is well suited for propeller analysis during the early stage of design. It allows you to estimate, calculate, and design a propeller in much more accurate process through assumptions and calculations. It estimates the propeller performance by analyzing the aerodynamic forces along the blade. In order to find these forces, the properties of an airfoil section are used. They are integrated along the propeller to estimate the total resultant thrust force and opposing torque. This torque multiplied by the angular rotation rate, the velocity that the blade elements experience is the vector combination of the free stream axial velocity, induced velocity, and rotational velocity. The induced velocity is the increased inflow created by the propeller. In this theory, we examine the propeller blade by sections, starting from the hub of the propeller, progressing to the tip of the blade. By analyzing the blade by sections, it permits to isolate the blade at a certain part, and how these contribute and influence the surrounding flow. The blade being studied is typically divided into small sections along its length that acts independently of surrounding factors. We consider the flow as two-dimensional and assume that the flow is isolated in each section, meaning to say that each section doesn't have any impact with one another. Utilizing this theory tends to be complex due to the complicated equations to make use of, plus the process of blade sectioning to acquire accurate results. It will require more manual calculations, which can take up more time that miscalculations and errors during the process may occur.
So, gumawa ang grupo namin ng program. Tinawag namin itong Thrust and Power Coefficient Calculator. Pwedeng gamitin ang program na ito ng kahit na sinong interesado sa blade element momentum theory para i-analyze ang isang particular na section ng isang propeller.
Pero bago ang lahat, magpapakilala muna kami. Ang grupo namin ay binabuo ni Badiola, Audrey Cardinez, Nicole Casanova, Denise Valencia, at ako naman si Franchesca Canlas.
So, first of all, we discuss kung ano nga ba ang definition ng computer programming. Computer programming is a way of giving computers instructions about what they should do next. Example ng computer programs like ng Mozilla Firefox, Chrome, na nag-review ng web pages sa internet. Isa pang example niyan, video games. Example yan ng computer programs. Operating system. Example din yan.
Ang ginamit naming programming language sa paggawa ng Trust and Power Calculator ay ang Beginner's All-Purpose Symbolic Instructional Code or BASIC. Ang nag-develop ng Visual Basic ay si Alan Cooper, an American scientist in the late 1980s. He also created the drag-and-drop design para sa user interface ng Visual Basic. Ang main purpose ng programming language na ito is to teach the programmers and developers on how to design graphical user interface or GUI programs. The Visual Basic version 1 was first introduced in the year 1991 at Windows World Trade Show sa Atlanta, Georgia. Later on, Microsoft contracted with Alan Cooper and his company called Tripod. Version 2 ay nirelease noong November 1992 na mas mabilis kaysa sa version 1 at mas madali itong gamitin. Noong February 1997 naman, nirelease ng Microsoft ang version 5 na exclusively for 32-bit versions ng Windows. Next version was enhanced, including the striking ability of creating web-based applications, and this Visual Basic version 6, which was introduced in the middle of 1998. BV.NET version 8 was launched in 2005. Yung version na to ay may dinagdag na feature which is yung using statement.
What is IDE? IDE, or Integrated Development Environment, is defined as a digital environment used to develop software, hardware, games, and anything that uses codes, and offers control over many aspects of development from text editing, debugging, and compiling. The text editor is where you type the codes for your program, while the debugger detects errors and stops the program right before the error. The debugger tests the code and points out the error and the position of where the error is. Lastly, the compiler, which converts the code into machine language and compile it. The IDE that we used was the Visual Studio 2019 developed by Microsoft. The 2019 version was announced on June 6, 2018 and was generally available for download since April 2, 2019. Visual Studio is popular in the market because it offers the Community Edition, which is free of charge. This edition promotes a free, fully featured IDE for students, open source, and individual developers. It can also read and develop in various programming languages. Visual Studio has all the tools that are needed to develop a program. That is why we chose this type of IDE to design our program.
So, kumuha po kami ng sample problems na binigay sa amin ni Engineer Delicano. As a first estimate of the thrust and power coefficient of a 3-bladed 6 feet diameter low-speed propeller moving at an advanced ratio of 0.6, simplify the standard momentum blade element integration procedure by separating the propeller blade into 3 mean property lengthwise sections. The hub ends at 0.2 r, no thrust produced from x is equal to 0 to x is equal to 0.2. And the first section will apply from x is equal to 0.2 to x is equal to 0.33, with the mean blade chord being 0.3 feet and the mean blade pitch angle of 50 degrees. The second section will apply from x is equal to 0.33 to x is equal to 0.66, with the main blade chord being 0.42 feet and the mean blade pitch angle of 33 degrees. The third section will apply from x is equal to 0.66 to x is equal to 1, with the mean blade chord being 0.33 feet and the mean blade pitch angle of 21 degrees. You may assume the section lift curve slope of the propeller airfoil is 5.7 rad raised to -1, up the stall CLmax of 1.2, and the 4 section of drag coefficient.
The program is designed to perform a specific task of calculating the thrust and power coefficient and various physical parameters of a particular section of a propeller. Blade element momentum theory, or BEM, was utilized to perform such calculations. The algorithm of the theory was translated into basic code that the program parses and executes. The equations involved are so complex, it makes the calculation process tedious and highly prone to errors. The program was therefore developed to expedite the calculation process and ensure accuracy using the computational resources available to a common desktop PC. So here's the main GUI or graphical user interface of our program. Meron siyang 8 text boxes na ginagamit para tanggapin ang user input. May 2 option button para makapili kung alin sa dalawang measurement system ang gagamitin, either the metric or the imperial system. Next, ang dalawang command button na calculate at clear. Ang calculate button ang siyang magpe-perform ng calculations, habang ang clear button naman ay para mabura yung mga laman ng text boxes at results. Subukan natin ngayon yung mga given sa sample problem na binanggit ni Audrey. Ang unang section ay 0.2% hanggang 0.33% ng propeller radius mula sa hub. Ang lip curve slope ay 5.7 per rad, 0.6 na advance ratio, blade count na 3, mean pitch angle of 50 degrees, blade radius na 3 feet, at mean blade chord na 0.3. Then, let's hit the calculate. Sa right side naka-display ang thrust and power coefficient values at iba pang mga consequential results gaya ng lift at drag coefficient, mean at induced angle, at iba pa. Comparing this sa sagot sa sample problem, malinaw na nagtugma ang resulta ng calculator. Pagkatapos ng calculation, maaaring isave ng user ang resulta sa isang text file. Ito ngayon ang laman ng text file. Makikita dito ang value ng mga in-input at ang resulta ng calculations. Kasama din ang date at timestamp kung kailan ginawa ang calculation at kung anong section ng propeller at measurement system ang ginamit. Maaaring ulit-ulitin ang computation. Sabi nga ni Engineer Delicano sa kanyang lecture, mas maraming section, mas accurate ang makukuha ang resulta. Gamit ang calculator na ito, hindi na mahirapan pa sa manual na computation ng mga komplikadong equation ang designer ng isang propeller.
The program's primary goal of computing the thrust and power coefficient fast and accurate was demonstrably achieved. The program saves the user from going through the incredibly complex equations of the blade element momentum theory using the traditional pen and paper computation method. It also completely eliminated the risk of inaccurate results posed by manual calculations. Furthermore, the program's uniqueness draws from its ability to create an output file of the calculations performed and a host of other features that the user ought to explore. By simply adhering the basic installation requirements for a common desktop or a laptop, the program is complete and ready to be employed for academic and research purposes.